Now it's my pleasure to introduce Matt Ingram, Associate Professor in the Department of Political Science here at UAlbany, who will get us started today. Matt's research interests examine institutional change in Latin America and the Caribbean, primarily in the justice and security sectors, as well as violence and insecurity across the Americas. He's serving as chair of the Open Access Policy Working Group, which has been charged with designing an open access policy for the UAlbany community and strengthening its digital repository. He also serves as an executive committee on the executive committee of Project Here. So please welcome me in joining Matt. Or, I said that totally. Please join Matt. Please welcome Matt.
Thank you, Emily. I also want to thank everybody who's supported this event. And it's a pleasure to see some old friends, and Norm and Richard, who I got to know about 3 years ago via Project Here. I'm just going to open with some introductory remarks about reproducibility. Again, we've been having a series of events all week on open access, but we're going to focus now on reproducibility today and tomorrow, and some nearby concepts and neighboring ideas, research transparency, workflow. Again, my remarks are going to be largely prefatory, introductory, just trying to set the stage for the more practical, applied, concrete discussion that will come later today, and then more concretely tomorrow with a hands-on workshop. So we might start by asking ourselves, what is workflow? I don't want to assume that because you came to an event on reproducibility, you already know what reproducibility is. So by way of introduction, just clarify some core concepts. And again, by saying workflow, or when I say workflow, or when any one of us says workflow today or tomorrow, we're also referring to research transparency, reproducibility, writ large. I'll return to that down below and some neighboring ideas. But general just definition of workflow is provided by Scott Long, who calls or defines workflow as a coordinated framework for conducting data analysis. Basically, this means everything from start to finish, where you might, from even the beginning, the early conceptualization of the project, when you might be collecting data, or if you're using simulated or synthetic data, right, the process by which those data are generated, through the process of cleaning, organizing, transforming data, then analyzing the data, and reporting the findings, right? Communicating your final results through to publication. So it's everything from start to finish. I don't want to steal any of Richard's thunder, but he has a phrase that he's used over the last few years with a meal analogy, right? Soup to nuts, a kind of soup to nuts analogy of what the work process is. You might think of this also as our full production process. Everybody has a workflow. We might not be aware of it. It might be unconscious or subconscious. It might be highly informal. We may not even spend very much time thinking about it, right? But we have a workflow. There is a process that we've become habituated to by which we gather data, whether it's kind of exploratory fashion, haphazard, idiosyncratic, right? We don't think about it too much. We might sort of store data in different places. That's our workflow. I'd argue that's maybe not a very structured workflow, right? It'd be better to have an explicit workflow and organize our own thoughts about that. But everybody has one, right? Even if we're not very aware of it. We have a structure that we follow in generating data, thinking through our data, evidence, information, analyzing it, reanalyzing it, and then communicating it to others. I want to emphasize at the outset as well that a lot of the language here seems to apply mainly to quantitative statistical research. but there is a lively discussion about how these principles and ideas extend to qualitative, interpretive, ethnographic work as well. Again, everybody has a workflow regardless of what the research tradition is. It might be highly informal and unstructured, or it might be highly explicit and systematic. Lots of people refer to these general ideas of reproducibility, workflow, research transparency under other headings or names, including replication, open science, openness, research ethics, research integrity. Whenever we hear these words, we should be thinking about these kinds of ideas, right? What is the production process? Right? What is the workflow? How transparent is the research process? How reproducible is it? So again, just to emphasize, right, it means everything from the early data generation, data gathering, collective steps to the final publication of the finished research product. So why should you care? Why does this matter? And I would say that there's a large number of reasons, right, why we should care about reproducibility, why you should be here in this room, why I wish there were more people in this room. Although Richard and I were just talking about how beautiful it is outside, and Richard said we're fortunate that the curtains are closed. there's some very nice fall foliage outside those windows, and it's a glorious day outside. So in some ways I understand why more people are not here. But two broad buckets of reasons why maybe more people should be here, or why we should care about being here. And I'd say one bucket consists of material, instrumental, rational, kind of strategic reasons for caring. Right? There's something in it for me. Right? And a second bucket is more of a values-based bucket, right? Non-material, perhaps normative or ethical reasons to care about this. In the first bucket, having a good production process, right? Having a good workflow, following some good practices of research transparency, research integrity, facilitates recall. I often find myself in a position where I'm working hard on a research project through the summer or winter break. I start teaching in the fall or the spring, and I get completely distracted, right, by teaching responsibilities, advising, administrative load, and I don't pick up that project again maybe until the winter break, and sometimes not until the following summer. If I have a well-documented, clear, explicit workflow, it is very easy, within about 20 to 30 minutes, I can get right back up to speed where I was the previous year, right, the previous August. For some of the same reasons, a good workflow saves a ton of time. I frequently find myself wishing that back when I was in school, especially in grad school, that these ideas and some of the practices that implement these ideas had been drilled into me, right? That it had been really emphasized. I don't know how much time I would have saved over the last 10 years if I had a good workflow from the beginning, right? Beginning, say, in undergrad through, not to mention graduate school. But a good workflow saves tons and tons of time. It expands your bandwidth, right? You're able to do several projects at once. If you have a project and you want to start up a new kind of related project, you can adapt a workflow and start very cleanly again, or get off the ground rapidly. Another material reason to care about reproducibility, workflows, kind of production process is collaboration. Having a well-documented research process makes it very easy to work with others. Right? Other people can understand what you're doing very quickly. You can share underlying materials, code, data, documentation, code books, etc. People can very quickly understand where you are and what you're doing and work together with you. Even if you're not collaborating with somebody, it's much easier to get advice from somebody. Really specific, precise, useful, concrete advice if you can share a clearly documented production process, right, or workflow. So I tell my students that this isn't just about co-authoring with people, it's also about being able to get good advice from your advisor, from your peer group, from your cohort, etc. Right? Collaboration covers all of these kinds of interactions. Getting extramural external funding is increasingly emphasized, right, and as part of career development, professional development, and funders increasingly emphasize and require open materials, right? They require you to document your production process, and especially what is going to be happening with your data, how accessible is your data, how understandable is your data, how understandable is your process. Publication, especially peer-reviewed articles, are the gold standard, right? It's sort of the coin of the realm in academia. And increasingly, peer-reviewed journals are demanding, requiring a full set of replication materials, right, as a condition for publication. So it's happened to me at least 4 times, right, where an article has been accepted in a journal, but it will not appear in print. It will never see the light of day until I provide my replication materials and somebody at the journal fully reproduces all of the core findings in the article. How can you meet those requirements, right, at peer-reviewed journals is by having a good a good workflow. Right? If you have a well-documented workflow, your research is transparent, you're already documenting all these things along the way, and you can quickly share a full set of replication materials on very short notice, right? The same day. Here's my code, here's my data, etc. Employers are increasingly valuing these skills. Right? I track a lot of the job announcements for students and for my own interest. And I increasingly see these kinds of skills being stressed in hiring efforts at other institutions. If none of these reasons motivate us to care about reproducibility and good workflow, then maybe some embarrassment or shame might do this. And having a good workflow reduces your error rate, right? Having a good workflow increases accuracy. So some people are concerned about reproducibility, sort of one of the big issues that gets a lot of attention is fraud, right? That maybe there are some fraudulent results out there, but fraud is really a very small piece of the pie, right, in this broader concern about reproducibility. There is some out there, right, but there's not that much of it. What there is a lot of is innocent error, right? Thank you. Innocent error finds its way into the best of research. Right, so a good workflow facilitates error detection and error correction. Right, if you've got all of your work documented, you can identify where the error is, but you can also quickly correct it without having to start over from scratch. And there are, if you're interested, you can go to a number of sources to see a wide range of different kinds of embarrassing outcomes, right, where errors were not caught early. Retraction Watch is an entire website, right, just dedicated to tracking retractions of major publications. There are some journals that are finding just a huge volume of their publications having to be retracted. Some publishers having to retract a large volume of their publications. And then I just added a couple of articles from prominent journals tracking reproducibility. But in psychology, more than 50% of a recent set of experiments were not reproducible. Right? They just, an effort to reproduce these core findings in prominent journals failed more than half of the time, calling into question, so do we really know what we think we know is one of the common phrases that you hear in this discussion. In economics, it was around the same rate, right? 40% of a prominent set of experiments failed and could not be reproduced. Large other disciplines, not just in the social or behavioral sciences, are also confronting reproducibility crises. Most prominent in the natural sciences is chemistry. Chemistry sort of leads the way by a survey of chemists themselves, right? Saying that they have failed to reproduce prominent pieces in their discipline, or some of their own, they failed to reproduce their own work. Right? Sort of self-reporting failure to reproduce your own work. So you can go to, these slides will all be shared on our open repository. You can follow any one of these things. I don't want to take the time to do this, but the main point is just that reproducibility crises are affecting everyone. They're widespread across the social, behavioral, and natural sciences, including the quote-unquote hardest of sciences. You could say this isn't just a social or a problem that is plaguing the social or behavioral sciences. There was also a recent piece by the American Society of Cell Biology that was tracking their reproducibility crisis. It's affecting a lot of medical research, a lot of cancer research. It's everywhere. It's very prominent. Right? These concerns are plaguing every discipline. So this is yet another reason to be concerned and motivated about this. Ultimately, reproducibility is also about good science, right? Having a good workflow makes your contributions transparent, right? What you're doing is transparent, reproducible, and you're contributing to the accumulation of knowledge. That's all good science. And lots of us in academia are concerned about citation counts, right? There's some evidence from a recent article published this year that if you provide your replication materials, again, which if you have a good workflow in place, it's very easy for you to provide replication materials, but articles with replication materials get cited more often. They get reproduced more often, it's easier to build on them, it's easier for research agendas to build off of articles that have a full set of replication materials, right, that are reproducible. So a couple of, well, several material reasons to care about this. And a shift to some more ethical reasons, and then wrap up here and turn the discussion over to others. I tend to care a lot also about the ethical dimension of this discussion. I think there's a lot to be said about the normative reasons to care about this. In academia, lots of us tend to think that our ideas are important, right? So we should care about communicating our ideas in a clear manner. Having a good workflow in place, documenting the way, the means, the methods by which you produce your ideas or your findings should be done in a clear fashion, right? We should care on some ethical, values-based level about being clear in our communication. It also makes our work more credible and more legitimate. And I also think it's just a more honest way of carrying out our work. The word integrity, or this notion, the normative content of this is in the name of Project Here, right? As you'll hear from Richard and Norm in just a second, right? The I in Here stands for integrity. But this to me seems like an ethical, sort of honesty-based reason for caring about reproducibility. Right? I'm not trying to hide anything. Right? I care about portraying my work in an honest fashion, even if it reveals some non-findings or some controversial steps, or it might expose me to some criticism. I value that, right? Let's enter the debate, but at least I'm being honest in the way I enter that debate. Transparency is also a value that is advanced by a good workflow. And again, this appeared in the previous slide, but I think that contributing to the scientific community, right? Not just contributing to the accumulation of knowledge in science, in terms of good science, but from an ethical perspective or a more normative perspective, we should care about contributing to that scientific community, right? Not just building, not just getting credit for our contributions. And then lastly, reproducibility helps to build a culture, kind of a normative system of ideas about integrity and openness. That could be at the department level, at the college level, at the university level, or in our disciplines or profession. And there's some prominent publications and events and conferences sponsored by the National Institutes of Health, Northwestern University, Science Magazine, and the National Academies, talking about the value, right, the value of building a culture of openness moving forward, and how reproducibility contributes to that effort. just a final thought on how we can help to build this culture of openness. The National Academies had 3 recommendations that for research institutions, universities, colleges, institutions of higher education generally, that we should integrate openness into tenure, promotion, and merit policies, right? And also in our research support, right? That will help build a culture of openness. We should integrate reproducibility, open science, research transparency into methods instruction, right? Writ large, that will help build a culture of openness. And then we should promote open access and open repositories, which will supplement or complement these efforts, right? If in no other way than providing the infrastructure for storing data, code, replication materials, etc., and making these publicly available. So I'll close with some questions for us to consider for the rest of the remainder of the day or tomorrow. I'm broadly interested in openness, transparency generally in education. So I find myself trying to sometimes wrestle with the relationship between various forms of openness, open access, open science. We're spending most of our time, reproducibility is perhaps most closely connected to open science, right? Open data, open materials. But then what's the relationship between open science and open access and open education generally? Recently, given the increased availability of computational resources, remote computing resources, perhaps perhaps Raphael can address this more in his discussion too. But what are some of the distinct challenges of computational reproducibility? One comment that I saw recently, that with computationally intensive work, it's not the published article, that's the scholarship. Right? The scholarship is kind of advertising or marketing for the scholarship, but the scholarship is actually in the materials, right? In all the code and the processing and the simulations, and that's in the replication materials. That's in your workflow and how you documented your workflow. That's where the contribution is. And so what are some of the distinct challenges that face us when thinking about computationally intensive work, right, and computational reproducibility? Victoria Stodden has done a lot of work on this. And then lastly, returning to the issue of building a culture of openness, if we can agree, right, that reproducibility and research transparency is good, how can we best promote it and build more of it here and elsewhere? So, thank you. And then I'm going to turn it over now to Richard and Norm and Raphael.
Okay, so thanks very much for inviting me, Norm, to come here. Emily, thank you for your introduction and comments, and Matt, thank you for your overview, which beautifully foreshadowed and set up and resonates with everything I want to talk about. So, and it really is a pleasure to be here. Norm and I have been thinking of this not so much as going somewhere like giving a talk, as really spending some time here and hoping to get to know people and develop some ways of collaborating in the future. We've over the years done many sort of workshops here and there, and they've been interesting and productive, but then you do a workshop and you go away, you never really know what happened, and we're have an explicit shift in mindset to focus more on let's do something that that sort of builds some relationships, has some follow-through, collaboration into the future, and that's how we're thinking now. And having known Matt for some time, Lucy Sorensen's been interested for a while, and now with Emily doing everything, we see real opportunities for collaboration here. So what I want to do is I'm going to talk for a bit, and then Norm's going to talk for a bit. And in the part that I talk about, so I would sort of tell you what Project TIER is, how it started, what we're doing, what the purpose is. That, I think, is the best way to frame where we're coming from and what we're trying to achieve, is to tell that little story about how we got here. That might be most of what I talk about, but I'm going to leave enough time also to talk about what are some particular kinds of collaboration I could imagine developing going forward from here. Okay, so I love telling this story because it was so funny how it happened. Norm and I had like no idea about, no plan to do any kind of project or anything. I was minding my own business, teaching my courses at Haverford College, and one of the courses I was teaching was an intro stats course, mainly for undergraduate econ majors. And in that course, they write a research paper. So the whole shebang of choosing a topic, surveying some literature, finding some data, doing some very simple analysis. It's an intro stats course, so very simple papers, but then with figures and tables, and write up a research paper in the end and turn it in. That's sort of a semester-long project. And it adds a lot to just 3 days a week talk, lecture, problem sets kind of situation. So students were doing this, and so in the early years of doing this, there was a problem, and the problem is that I could not understand what the students were talking about in their papers when they described what they did with their data. They sort of explain a topic and review some literature. I could more or less follow the story, but then they'd say, we got this data and we did these things to merge these data sets, and then here are some tables and figures, and I couldn't tell where they'd gotten the data, what they had done to it. Some data set about rainfall in the Amazon, and some other data set about like crime rates in the Philadelphia neighborhoods, and they somehow merged them in some way, and I just couldn't quite put it all together, and then and it was really a problem. And when I would ask students, so what exactly were you doing here? They didn't even know. They couldn't even tell the story. So, and the real problem, fundamentally what we realize now is the problem is they were just working interactively. They were downloading data sets and then just typing commands one at a time and not really keeping a careful log of what they'd done, and just saving data sets after they'd modified them, and they just lost track of what they'd done. And at some point they didn't really know how they'd gotten to where they were. So what it occurred to me one day, just walking across campus, of, oh, this is solvable. I just have to tell them to turn the data sets they use and have them write scripts and turn in the scripts. So we use Stata, so they write do files. I thought, great. So that's going to solve the problem. So one semester I said, okay guys, and when you turn in your papers, I've set up this server where you can deposit your data and scripts and do files. And so the first time around I just made that announcement, and half the students did nothing, half the students put up something, but fragments of stuff that didn't run. I didn't know what anything was. And so the next semester I said, number one, I have to write this down. And number two, I have to be a little more explicit about what they should put there. And every semester, these instructions I typed up got a little bit longer and longer as students ingeniously found more ways to make things confusing despite all the instruction I've already given them. So there's this iterative building up. Throughout this entire process, Norm was closely involved in the class as reference librarian, and he worked closely with students both in finding previous research articles and stuff, but also in finding data sets and staying on top of that. And so Norm was very involved in all of this from the get-go. So, okay, so it took some iterations to get this to work, and it ended up being about a 7-page long document that was like, here's what you have to turn in to document your papers. And it got very explicit. And this 7-page document was instructions for what documentation to submit, so, and how to organize your data and code and additional information. So this was very much like the stuff that people submit to journals, just like Matt was talking about. This is sometimes called a research compendium, this whole folder full of not only the paper, but all the replication documentation. And since about 2010, this has really been working. Students get, we got the instructions so that they're detailed enough, students know what to do, but not so detailed that they're overwhelmed. And like Matt said, it's a workflow thing from the beginning of the course. They get organized and get in the mindset that they're going to document things and turn in documentation in the end, and they can do it. And this is, takes a little bit of learning, but they get the hang of it. And there are usually five or six project groups each semester that I work with, and each semester 0 or 1 group don't really turn in stuff that works, but everybody else, large majority, turn in stuff so that when I read their final paper, I can just click through their code and run and see exactly what they're doing. So I understand much better, they understand much better, so it really, that direct problem that started it was just to know what they'd done, that really solved that problem. And we continue to this day. I've got a new crop back in Haverford right now working on their proposals for the papers this semester. Okay. So since this had worked out well, we thought it was valuable, Norm and I thought maybe we should tell some people about this. So we just did presentations at a couple of conferences. We wrote an article for the Journal of Economic Education. And then here's kind of where Project Here came. There was sort of this aha moment sometime around 2012 or something. We thought, sort of, as we became aware of this whole transparency movement in the social sciences and openness and everything, we realized, that's this big thing going on in the world that in a way that's exactly what we're doing. In fact, quite particularly, this transparency movement has many different dimensions to it. But what we were talking about was computational reproducibility, just making sure you could run the numbers and get the same results. And so, wow, it's a nice fit between what we're doing and this bigger movement out in the real world. And so, like when Matt showed the quote from the National Academy's report about, I think point number 2 was need for integration of openness and transparency into education. But hey, we're doing that. So, that's what the stars kind of aligned, and that's how this thing then coalesced into Project Here. So, what are we doing now? So, I won't go into great detail because I'm going to talk about some specific activities in more detail later, but the general thrust of what we're doing, there are 2 main dimensions to what we're doing. One is developing resources and curriculum. So by protocols, I mean things like this 7-page PDF with instructions for what students should do to document their research. That we now have it up all on the web, and we're continually refining and adding new dimensions to it. That for instructors to come grab and point their students to give them advice about how to document their stuff. We're writing different kinds of exercises. There's we have a collection of course syllabi and student projects up on the website. So that's sort of developing materials, and then do a lot of outreach. So workshops and seminars to try and spread the word about this. Okay, so then here's our vision for education. Our vision is that someday, you just wouldn't teach statistics without building in this transparency component, and that's not to say that transparency would become the focus of what everybody's doing. Kind of quite the opposite. Like transparency would just be like routine and in the background and how you do things, and part of the fabric from the get-go. So, you know, just for like weekly homework exercises, if they involve computations, you turn in a script that generates your solutions. All the way up to, for a full-blown research paper, you turn in the full-blown research compendium. So that should just be normal. Because, you know, as Matt said, it's like a more efficient way to work, it improves communication, cumulative science, all these things. Why not just do that from the get-go? Okay, so now, if this were like a typical workshop where we were coming here and saying, okay, instructors, here are things you can go back to your classrooms and do, we would go into sort of nuts and bolts of sort of how our instructions are formulated and everything. And we love doing that. You know, be careful about asking questions over lunch unless you really want to hear about it, because we'll have a lot to say. But for now, instead of going through all the nitty-gritty of exactly how things work, I just want to give you some broader perspectives on principles underlying the way that we do things. So one thing is that people talk about reproducibility, and often the conversation turns to, okay, there's a lot of published research out there, what do you have to do to reproduce stuff? But that's what I call ex post reproduction. Like, stuff's out there, can you reproduce it? And we're talking about ex ante documentation. Like, at the beginning, when you write the paper, you document it so that the ex post reproduction becomes automatic. It should be very easy. So it's really more, what we're teaching is how to document your research so that it's easy and trivial for anybody else to reproduce it. And in the guidelines that we write up, we break things down into two pieces. One is specifications, and the other is process. So specifications is just, we give students a picture of what they're going to turn in when they're done. And it's like folders with different documents, code data, code books, metadata, organized in a certain way. So they know sort of what it's going to look like in the end, what all the pieces are. Then the other part is process, and you know what? We should start using a different term. Following Matt's comments, I think we should call this workflow, because that's really what we're talking about, which is guidance from the very beginning. What do you do when you begin a project? And like, you know, step one is make a structure of empty folders and call one of those folders data, call one of them scripts, etc. And so you have places to put stuff. And then your project is just populating those folders bit by bit over the semester. So now that's almost certainly too small for you to read, because that's okay really, because it's not so much the details I want to get across now, but just the idea that the specifications, it's just, we've got a data folder, a scripts folder, and an output folder, with some subfolders in them, and creating all that documentation is what students do bit by bit all semester. And so here's an example of a real student project. So this was stored on the Open Science Framework, but it could be on Google Drive or someone's own desktop or whatever. And there's one big folder for the whole project, and then basically folders inside there that correspond to that previous picture with all the pieces. And so that's a snapshot of what it looks like. So if you want to see more details, the first link is to our website where we have student projects posted. So they're mostly senior theses, I think. There may be a dozen papers there. mostly undergraduate senior theses, some from Haverford. I think all the rest might be from New York State, from Colgate and St. Lawrence and Union College. So, and with all the documentation there. And you should be able to go there. Some of them are done with Stata, some of them are done with R or R Markdown. But you should be able to go and download the whole thing, and it should be very easy to run the whole thing, and all the figures, tables in the paper, you should be able to regenerate them just by click, click, click. And if you try it and you can't, please let us know. We work really hard to make sure stuff that we post runs. And just this last summer, I actually had an RA go and just check them all and found a couple of glitches that we fixed. And we'd love to hear if there are any other glitches that need to be fixed. So don't just go flame us on Twitter or something, but just let us know. Okay. And another thing that is often, it's like kind of a central tool for doing workshops, but here I'll just point it out. We also have a complete, call it demo project. It's like a little toy research paper that's 4 pages long or something, but that uses real data from real sources and cleaning and organizing them in certain ways and then generating some tables and figures. And we've just created all the documentation that meets our specifications for that little toy paper, so you can see all the details in a concrete form for one project. That helps. It's a good demo for students and faculty to see concretely everything we're suggesting. Okay. So more on this idea of sort of what are the principles behind what we're teaching. Well, so the first thing is that the one thing that this all relies on is that students are writing some kind of scripts. And it doesn't matter if it's Stata scripts or SPSS scripts or SAS or MATLAB or R scripts. That's the key to it, is having scripts that you can run and reproduce everything. So you know, students can't really be just typing commands interactively or using drop-down menus, and can't be using Excel. And you know, Excel is great for many things, and many programs use it for certain things and for very good reasons. But if you want to do reproducible quantitative research, Excel's probably not the way to go. You can use Visual Basic, I guess, and then you're scripting, and then you could be okay. But I've never actually seen that done. So, okay. Then, given that you're using scripts, the core thing that gets the kind of reproducibility that we're aiming for, I call it the reproducibility trifecta. And somebody said to me once, why don't you call it like the reproducibility trinity? But I spend more time at the racetrack than in church. So I call it the reproducibility trifecta. And what are the three pieces of it? One is, so you want to have some fixed folder structure. So your big project folder with your data folder and code folder and relevant subfolders. You can set up that structure basically however you want, but you got to choose a structure and just keep it fixed. Then, okay, and just a little comment on this. You know, for computational people, this is like not computationally interesting. This is like just getting out of bed in the morning if you're a computational person. But this is where a lot of problems come up in sort of applied social science stats courses, that there's not attention to this and you get into trouble. So the second piece is, okay, within that folder structure, choose one of them, one folder that's going to be the working directory all the time. And that could be the directory where your scripts are located. It could be the whole project directory. It could be any directory you want in that hierarchy. But just choose one and keep that fixed. And then once you have a fixed folder structure and you know what the working directory is, in your scripts, when you want to tell your software to go open up a data file or save a graph file somewhere, you can tell it where to go using relative directory paths from that working directory to wherever you want to save something or grab something. And those three pieces, if you put them all together, do a lot for you. You get this research compendium, so it's fully automated. And by fully automated, I mean, particularly the way to make it really fully automated is to write one master script that calls all the other scripts, so that really all you have to do is run that one script. And running that one script does everything from grabbing your original data, processing it, creating the analytic data set, and then grabbing that and generating all your figures, tables, results. And now, what I say, just one thing to do by hand. You know what that is? That's to make sure your working directory is set to where it's supposed to be. That's the only thing you have to do by hand. And you know what? Honestly, I don't know. For different kinds of software, what like the default working directory is when you launch things. With Stata, it's variable, depending on whether you're on a Mac or a Windows machine and different things. If you just launch Stata, and depending on whether you launch it from the program menu versus double-clicking on a file, when you start up, the working directory can be unpredictably different places. So the way we resolve that is say you've got to do one thing by hand. See what the working directory is. If it's not the one you chose, set it, and then just click the master view file, boom, everything happens. Okay, and it's portable because your working directory is in those folders you have, and all the relative directory paths go to places, to subfolders of that big folder. You can take that whole package and plop it on any computer, and everything will be there. Like the user has to set the right working directory, but they don't have to tie it to their root directory or anything, because it's all relative within that structure you created. And it's soup to nuts in that it starts with the raw data, does all the processing and generating the results. Okay, so I said earlier that this really solved that problem of us not being able to understand what our students were writing, and so we can see exactly what they're doing. But it sort of has slowly dawned on us over the years that some additional benefits have accrued to this that we didn't immediately anticipate, that weren't really the motivating thing, but that have proved very valuable. And relating back to Matt's comments, some of these are more on the instrumental side and some are more on the kind of values side, but they're both there. So this is good scientific practice now. It's a professional research skill to be able to document your stuff. And if you're submitting stuff to journals, you have to do it now. It's good, so it's teaching good scientific practice. And the transparency for students and instructor, that's I'm just referring to the instructors can understand what students are doing, and students understand what they're doing better when they keep track of it step by step. They don't get lost. They can explain at the end what they did. Okay, now, this communication and collaboration, that is maybe the heart of the matter about what I find makes this compelling. That it's not just when they turn in their final papers I can understand them better. It's while they're working I can advise them much better. Because when they come to me for help, so I have them keep all their folders and files while they're working up on a file sharing platform, so that when they come to me for help, I can get into their project and I can download it right up to my computer, the whole thing, and then I can run their scripts. And so if they come in and they say, oh, we have this regression and some variable got dropped, we don't know why, I say, let's have a look. And I download it, and they may be asking about some regression that they're doing after all this processing and other stuff. But I say, start at the beginning. Let's just run those scripts that import the data and clean it up and just see what's happening, and then we'll get to your problem. And almost always, as we're running through their stuff, there's something that comes up that was really the problem before they ever got to that regression. And they fix that problem, and the problem they thought they had just goes away. But then we can like really diagnose it and fix it. And I shudder a little bit when I think back to what I used to do, which is they would come in with this printed output from a regression and say, why did this variable get dropped? And I would scratch my head and maybe it has something to do with the oil prices in the 70s, or make up some fairy tale that might explain it, and think to myself, what could I say to get this student to leave my office? Because I really didn't know what to say. So, but now we can really look and solve the problems, and it's really huge. It takes a little bit of getting them used to the idea that they have to have their stuff up on that server, and it's got to run if I'm going to help them. And if they don't have it, or if it crashes, they have to go fix it and then come back, and then I can really help them. And they get mad the first time when I send them away, but then they're very grateful for the rest of the semester. Okay. Okay, and then kind of higher order things is, we're sending them a message that you need to be able to back up your arguments, and you need to know how you got there, not just you did a bunch of stuff, who knows what, with a computer, and then you got this table and you're going to interpret it somehow. You've really got to know what you're saying, what things mean, how you got there, and just as particularly, I don't know, for undergraduates somehow, it just seems like an important principle that they should that should be how they do things. But whether it's putting good footnotes in a philosophy paper or good documentation for a quantitative project, it's an important thing. And really, this when students when they understand what they're doing, they believe in it a lot more, and they start to begin to get the idea, hey, I really am capable of saying something and learning something and doing something meaningful. It's not just an exercise to do what I have to do to pass the course. And so it's a way of letting students find their own voices, feel empowered that they can really do something meaningful, and it's not just what do I have to do to get the professor off my back kind of thing. Okay, so now if you look at the website and the kinds of instructions we have about how to organize your things, how to document things, they're quite prescriptive. Like it says, make your folders like this with this structure, and organize things in this way, and follow these conventions, and it looks kind of bossy. Now, in fact, the reason for that is not because we care exactly what you call your folders and where you put them. There are many ways that would work just as well. It's that students need that guidance. Maybe with an experienced researcher, you can say, set up some folders in a reasonable way, but students aren't going to understand that, they're not going to know what to do. So it's mainly just for helping students, providing concrete guidance that they can follow, that we're so prescriptive about things. And in fact, our whole orientation is really not to be rigidly prescriptive, but to be very flexible as much as possible. So for instance, this tier protocol we've written, it's software neutral. So, we talk about scripts and data files. We don't talk about do files or or syntax, or SPS syntax files or whatever, just talking generic terms. And these principles that we're advocating, you can use different kinds of workflows. So most of the stuff we have online now is about a copy and paste workflow. So your scripts generate the tables and figures and save them in an output folder. But then we're kind of silent about how those figures get from the output folder into your paper. And it may be copy and paste, or maybe get LaTeX to grab them or something, but that's sort of a separate step. But if you like using some kind of markdown, same kind of principles, that reproducibility trifecta still applies. And if you want to use Jupyter notebooks or whatever, that's all great. And we're working on generating more curriculum and resources for those other kinds of workflows as well, because it all fits in the same paradigm. So we use OSF, the Open Science Framework, for our file sharing platform, and Norm can talk about it some more. We have found that for our purposes, that's a sweet spot between high capabilities and version control, but not too complicated to use. In fact, like easy to use. But you can use whatever you like. If you want Dropbox, that's great. If you want to use GitHub, that's great. And we're increasingly trying to develop resources that can be used in like diverse kinds of settings. So, our context was a full-blown research project done over the course of a whole semester, and that's sort of how most of our stuff is structured. But we're now embarking on a project to develop short exercises that could be like something you do in one lab period, or like a weekly homework assignment or something, where it's much smaller scope and more focused, but you do all the business of saving your data, writing scripts, putting it all together with relative directory paths so that everything runs, turning in the whole research compendium. Okay, so our general philosophy is we're trying to meet people where they are, and we're not saying this is a whole brand new paradigm, but radical way to restructure how you do research. It's more like keep doing your research pretty much the way you've been doing it, but here are like a few small steps you can make to fix things up that are going to have a big payoff. So now on to the part about some ways that possible things that we'd love to explore if there's interest here with people at Albany. So, and there's sort of four categories of potential follow-up activities. So one has to do with introducing reproducibility into curriculum, another educational assessment, curation of research papers, and sort of fostering collaboration and community. And I have slides about each one of those topics in turn. So in a way, this is like, these are all like ideas I'm just throwing out there. These are kinds of things that we would love to do. We have a few other institutions that are prime hotspots where there's some interest in this kind of thing, and we would love it if Albany was one also. So, about getting reproducibility into the curriculum. So that's what Project Here has been all about, and we would love to work with anybody who wants any guidance or help, and it's not like one-way guidance and help from us. It's like two-way. Tell us about what you're doing, and we'll learn things you've done, and maybe that'll become new tier curriculum or something. But for anybody who wants ideas about in their particular class what they could build in to introduce this reproducibility. We'd love to work with you. We're happy to work with individual faculty members, or if there's a department that wants to take it up initiative, or any program that sort of wants to talk about reproducibility training in theses or dissertations, maybe for a sequence of courses. Like, wouldn't it be cool if, I teach an intro stats course, and then they go and take an econometrics course that's taught by a wonderful colleague whom I admire amazingly, but she's not that interested in this particular angle, so they don't do it again. It's too bad. So you can imagine some sequence where they use sort of the same paradigm each time, and it really gets reinforced. And if they're big courses that have TA sections where TAs are doing like data labs with students, maybe train the TAs to introduce this curriculum. Matt sent me a long email telling me why that was such a terrible idea, but I still left it in the slides. So I don't think it was a terrible idea. I think so. You've got to have the right context, which may or may not be there. Okay, so that's one. That's sort of the bread and butter of TIER, sort of getting this into classes. But there are other things. Now, this is something that we would love to be involved in, and we would need somebody else to take the lead on and bring in the real expertise, which is doing some kind of assessment about how does teaching this reproducibility stuff, what are the educational sort of cognitive effects? There's the whole world of educational psychology and education research about how this way of teaching calculus changes students' brains and has this kind of educational output and things like that. And it would be very interesting, would be possible to design some ideally like controlled study of some students getting this kind of training, some not, and then somehow what you have to say, what outputs, what effects are we looking for, how do we measure them, how do we control for all the different variables that might be important. But there are a couple other schools that are interested in this, and maybe we've got like enough schools to have like enough different subjects. It's a possibility. So, I think this would take some expertise like in educational psychology or research on effects of educational interventions. That's a whole area in itself. Okay. So another thing I'll just mention briefly. So Matt, I think you said something about a research archive or something for open materials or something at Albany.
There's a digital repository. There's an open repository
for like research papers and data and
it could be anything, but it's mostly papers or data, conference proceedings.
Okay, so
Lindsay in the back is more the expert on the topic.
Okay, so I'll tell you what a couple places are doing, and maybe this was some kind of interest here. So at the Cornell Institute of Social and Economic Research, they've started something called the Results Reproduction Service, and it's actually a former TIER fellow who's running this program. He works with faculty authors of papers to help them archive a research compendium to go with their papers, and it's on a purely voluntary basis. It's authors who are motivated to document and make their stuff reproducible, but he helps them put together complete documentation based very closely on the TIER protocol, adapted a bit for their particular context, and so this has been going on a couple years. They've maybe got 6 or 12 articles documented in this way, but it's continuing to grow, and And that's just like a nice concrete thing that a repository could do, is sort of have some standards or specifications about what's going to make a nice automated, portable, reproducible research compendium, and help authors on a voluntary basis create that kind of documentation and archive it with the paper. And in fact, there's a whole consortium with Cornell and a couple of other schools that are trying to promote this kind of thing. And if you want to see an example, this is very nice. Okay, I'll be honest, I'll be transparent. I'm using this example because it's published in Science. I thought that was impressive. Okay? But there's an article that was published in Science where Florio at Cornell worked with the author to put together this replication package. And so you'll have access to these slides. This is a link to the Science article. And then you can also go to the archive at Sizer, which doesn't have the paper. It has like the abstract and a link to the paper, but it's got all the reproduction documentation. And I went and downloaded that and ran it, and it's in Stata. It's a copy and paste workflow, but it all runs. It took 3 hours to run. The one bit I would add to the documentation is a little warning to the user that it's going to take 3 hours, because at first I thought it wasn't working, but then it ran. So, and there are other papers up there like that also. Okay, so that's a picture of all the stuff in the archive at Sizer for that Science paper. Okay, and then the last thing, I want to turn it over to Norm, so I'm very brief. We, as a way of fostering communication within institutions and then across institutions with us, we are creating what we're calling tier hubs, which is basically one institution or campus or possibly region where there's as small as just like a few interested people, or maybe a larger group of people. And we have some ideas about how to, very loosely, but in meaningful ways, set up some interactions and communications that would take place on the campus, and then have outreach across different campuses and getting people in touch. And not to use up time, that's something I'd love to talk about more in the coming days. If there's interest, I'll tell you more about it. But those are some ideas. I'd love to sit around and brainstorm. I'd love to learn more about what all of you are doing in particular, and what your goals, what your challenges are that you face, and talk about how we can work together to make your work more satisfying, share what we know with other people. Yeah. And so with that, I'll pass it on to Norm. You want to use the board?
I should. Okay, I too want to extend my thanks to Emily for inviting us here today. We were really excited at the possibility of coming up here, and as Richard mentioned, getting to know you, finding out how TIER might be able to assist you with your efforts to integrate reproducibility into the curriculum. I want to take just a few minutes to talk about how we're doing it at Haverford, but bearing in mind that, as Richard mentioned, the protocol and really everything that we've discussed with respect to the principles of transparency and reproducibility, it's software neutral, it's platform neutral. In the case of OSF, we have found it to be really the sort of the right platform for our students. There are some attributes of the OSF that make it very receptive to students using it, drag and drop interfaces, sort of very clean, not a lot of clicking going on. It's free to use, it's unlimited storage. There's also a very important technical reason that we use the OSF, rather than using, for instance, Google Drive. We have a lot of students at Haverford that come over from Bryn Mawr to take classes. Bryn Mawr is a Microsoft shop, Haverford is a Google shop. Those two don't work well together. By using the OSF, we can permission anyone from any domain to have access to the OSF and use it. So I wanted to show some examples of some courses that we have set up. Let's see if I can get this to my cute kids. There we go. Okay, so some examples of this. The first example I want to show you is a course, Bryn Mawr course actually, the sociologist at Bryn Mawr teaching quantitative methods. And she talked with Richard and I about setting up a course where she would apply the tier protocol structure, but really in a way that allows her to use OSF also as essentially her learning management system. I mean, basically you can see here in this wiki, she has set up her office hours, lots of other information here of use to her and her students. And then each of her students has their own, what OSF calls a component, but essentially a sub-project. So in this case, Joanna, the instructor, myself as sort of the OSF admin, and her TA have the ability to see all of the students' projects. But each student herself will only have access to her project. OSF, by default, has storage associated with it, and that's this OSF storage. That's that free unlimited storage that I mentioned earlier. However, if for whatever reason you wanted to hook in a different storage back end to OSF, such as Dropbox or an institutional box account, you can do that as well. You can see here this setup, these are the particular assignments that each student will be conducting, these projects, statistical projects throughout the semester, and the students just go in here and put their data, their code, their syntax files, their papers within each of these folders. Very simple way for Joanna to have full access to all of her students' projects, be able to download these projects and run them as she wishes. Another example here, this is another Bryn Mawr course. This is econometrics. So David Ross is the instructor in this course, and he has set his up. He actually has 3 different assignments that he has his students do. This assignment is the pharmaceutical project. So he asked us to set up his OSF at the assignment level. So each assignment then has his students with each of their sub-projects. So there's a tremendous amount of flexibility here within the OSF. In 2017, which was the 2016-17 academic year, Richard was among the economists at Haverford that oversaw the senior seminar. So every student at Haverford conducts a thesis, a senior thesis, year-long experience, and it's taught jointly by instructors, usually 3 or 4 economists. Richard was among that group in the 2016-17 year, and as such, we decided to go ahead and set up an OSF project for all of our senior thesis students. So once again, up here are the instructors that have full access to all the student components, and then we worked with the students throughout the year to have them use the OSF in a very sort of regularized way. I mean, to burnish the point around workflow, you cannot retrofit reproducibility. It's just been our experience that you have to go into it from the beginning point with a mindset that this is what you're trying to achieve is a reproducible project at the end. You can't wait until the end and then try to retrofit it. So we work with the students throughout the year on using the OSF as a place to document their files, put their command files and data, to create all the other elements that you'll see within the tier protocol, within the specifications, in a very active way. Obviously, some students did this better than others, but it was really and continues to be our motivation to try to get our students to work regularly in this transparent way from the beginning of the project. The last OSF piece I want to show you here is a template that is publicly available. I should have mentioned that really at the beginning. By default, when you create a project on OSF, it will be private. And that's another real strength of the OSF, because for the most part, the student projects that we're using OSF to store will never see the light of day. We want them to remain private and just available to Richard and myself and the other instructors who are teaching those students. However, there's a very easy way to make projects publicly available, to be assigned a DOI for those projects. And this is an example of one where we have done that. This is the Tier 4.0 protocol template. So we have just recently, it's not yet up on our website, but will be soon, released the version 4.0 of the protocol. And in an effort to make it as simple as possible for people to use, we create this publicly available template on the OSF. Within this template are the three main folders of the project: data, output, and scripts. And as you start to open this up, you'll see the different subfolders along with text that will help you understand sort of what belongs in each of these folders. We have this explained in much greater detail on the tier website, but it's a very simple matter for someone, should they wish, to take this protocol template and reproduce it here. In the OSF, there's a couple of ways to do this, and I just want to caution you, if you try to do it, the natural thing to do to use this template you would think would be to click, duplicate template. If you do that, unfortunately, the way the OSF is set up, you will lose the folder structure. What you need to do instead is fork the project. When you fork the project, the folder structure that's in the OSF will remain intact. You'll essentially receive an OSF email saying, here's your project. You click on that, and it will take you to the project. It will be a replica of this with one slight change, and that is the title will say, fork of Tier Protocol 4.0 template. And then you're free to do with it whatever you wish. So it's kind of a quick way to get up and running. Obviously, creating these folders and subfolders is not a very labor-intensive exercise, but nonetheless, we wanted to do something that made it sort of quick to get rolling. So the OSF is the platform that we're using with our students sort of in real time. We have, however, decided to showcase some student projects that are really quite illustrative of one-click reproducibility. And we've done this in a couple of ways. One, on our website, as Richard mentioned earlier, we have a section of our website devoted to showcasing student projects, and there's about a dozen of them up there. But pretty early on into our Project Tier experience, we wanted to make even more sort of public these projects that undergraduates are doing, in large part to demonstrate that if undergraduates can conduct their work and create these empirical projects in a reproducible way, certainly professionals ought to be able to do that as well. So we've carved out this Dataverse site for Project Tier. We have a number of contributing institutions now, and as Richard mentioned, all but Haverford in the great state of New York. And it's really an opportunity when an instructor has a project that he or she really thinks is extremely well done and would make for a nice addition to this website. With the student's permission, we will put it up here on the Dataverse. How many of you are familiar with Dataverse? A couple of, just a few. Okay, so Dataverse is a product of Harvard's Institute for Quantitative Social Science. And we first experimented with Dataverse as a tool to use in the classroom. It really didn't lend itself to that kind of application. So we ended up discovering the OSF, and we've been using that very happily for the last several years. But Dataverse is an incredibly powerful tool. In contrast to OSF, which is very lightweight when it comes to metadata, Dataverse is extremely rich. You have opportunities to leverage existing metadata schema across a wide variety of domains. However, you also have the ability to create your own particular metadata scheme that you use. So here's one example of a data set in here. So this is a Haverford thesis writer from a few years ago. You can see this is very sort of basic information, description, subject. Here are his files. And they're all essentially set up here in a list. But when you click on the tree structure, you can see that we've got a format here, a structure with folders and subfolders. So Dataverse just recently released a version 4.x that allows for the retention of these hierarchies and folders, which is an essential component to the tier protocol and frankly to a lot of empirical research. Prior to that, there really was no way to maintain that hierarchy other than sort of a hack. But now they've got the structure, so it's really conducive to our putting these projects up there, being able to then have researchers come along and download them. You also have the ability to do things like restrict particular files. You have usage statistics. It's a very, very powerful platform. So I encourage you to take a look at that if it's interesting to you. And then lastly, just to note that we have been trying very hard, I've been working very hard to integrate these principles into classes across the economics courses in which I'm supporting students. This is a LibGuide I've put together for the senior thesis students. Each year we work with them on using OSF, other ways of managing their data, and really trying to remind them about so many of these workflow principles, be it data citation, be it documentation, be it just redundant storage of their files so things don't go sideways on them. There's a whole host of these kinds of things that are very easy for librarians to bring to the table. So it's been very rewarding, and as I say, while we're using these particular tools in terms of the OSF, really any platform will work. So thank you very much.
Hey everyone. Today I'm going to be talking a little bit about Popper, which is a tool that was originally created by Ivo Jimenez when he was a graduate student at UCSC. He originally made Popper from the get-go an open source initiative for the CROSS, Center for Research on Open Source Software, and I got on board pretty early as a contributor, and I've been volunteering ever since. So Popper is pretty computationally focused. We try to use things that are traditionally only used for software engineering, and we try to shift them to where we try to leverage them for doing more research-oriented stuff. Who here has heard of supercomputing? Yeah. Well, it's this conference for large-scale computation, and they have this reproducibility initiative that they've started for a couple years now. Since 2015, they introduced these appendices, artifact descriptions. They're simple descriptions of how where you ran your experiment, how you should set up all the software for running the experiment, and what methodology, if any, you use to validate these results. And the purpose of this artifact description appendix is to make whatever research you did easier to reproduce. And here's an example of, on the left is a paper from supercomputing, and on the right is the start of this artifact description appendix. It has a couple sections. It's a long description of how you can reproduce the experiment. And it's been a thing since 2015. It's become more common throughout the years, and in 2019 will be the first year where it'll be mandatory for all papers to also include an AD appendix. An AE appendix, which is artifact evaluation, is more of an analysis of all the results from your artifact description. And yeah, so it's been a thing that's been growing. The process for getting these for submitting to SC is that a reviewer has to look over these AE, AD appendices. So a reviewer has to go through all these and check them and run all the steps manually, ideally, and well, that's necessary for the paper to get approved. If they include this, which they will have to for SC19, which is next month. So the steps for preparing an AD appendix, usually this is how the process is done. First, the researcher will start running experiments, simulations, or gathering their data, doing processing, and they'll start looking at the results and doing analyses and just normal stuff. Then they'll write their paper, and then once all that's done and they have their paper, they have their results, they'll write their AD appendix, and then they submit it and present it. Can someone tell me what they think the problem with this could be?
Retrofitting problem that Norm mentioned.
Yeah, that's the thing. And also, this is really done last moment. There's this thing. In many of these cases, you can sort of describe what you did, but many times you miss things and you're doing it on a rush, so there's a lot of room for mistake. So an approach that we can take instead, rather than the typical approach of inputting commands one by one on the command line, is using a thing called DevOps, which is a relatively new field in computing, in software development, where developers will actually automate many of the tasks that were previously done manually, like setting up servers, installing software. We'll do these through scripts or tools that help us do this. And well, we can also use this for research. We can use tools for automation. Again, I mentioned scripts. Bash, Python are ones that we like because they're very flexible and you can do many, many things with them. Another thing that we really encourage for experiments with Popper is, well, we mandate it really, is use of version control. If you've never heard of version control, well, it's basically just at certain points you check in all your progress into a code repository. So we like to use the analogy of a lab journal for version control because all these commits, they're saved, so you can go back in time and see how the experiment progressed over time. And if something broke, well, you can find exactly what change you did made the results change. And a thing we really focus on in Popper is trying to make these computational experiments as portable as possible. We do this through technologies like containers or virtual machines. We use containers a lot, particularly Docker containers, because they let us package an experiment in a way that we can say the only things you need installed on your computer for this to run is Docker and Popper. So, well, many times you don't even need Popper because you can package Popper inside Docker, so you only need that. For anyone that doesn't know, Docker or containers rather, are a technology that allows, we have this problem many times when we're doing any sort of software development or research, or computational research, where you'll have maybe software that won't run on a certain machine because of version mismatch or whatever reason it could be. So what containers are is they'll actually package a whole operating system, and including the application you need to run, and that's what you distribute. So we remove that problem of version mismatch because it includes every single dependency that you might need inside the container. We use this a lot, and Popper workflows are basically all built over these Docker containers. And another thing we've built upon is this technology. It's recent. It's GitHub Action Workflows. These workflows, it's a specification for workflows. It was again initially created by GitHub, which is a website for software for hosting code projects, to do automation for these software projects. And Popper is built on top of these workflows. Well, normally they only run on github.com. Popper is actually a runner for these GitHub Action Workflows locally. Popper or GitHub Action Workflow is a text file that is both human and machine readable. We define workflows, and then we also define a list of actions. And for example, this workflow right here is corresponds to the flowchart on the right. We define the arrows through dependencies, but with this needs thing. So for example, the test action requires the install action, and the branch filter requires both the lint and the test action. This is an example from software development, but you can see how you can maybe like experiments and then generate figures or things like that in this sort of framework. And here's an example of Popper running exactly this workflow. It's right there, it's running the install, then it runs test, and lint. It's running them sequentially, but it could, in theory, run both of those in parallel. And then it runs this branch filter, and it'll run deploy in a moment. As you can see, these, when we define these, many of these actions actually directly use a Docker container. This is how we leverage Docker. Many of these actions, you don't have to make them yourself, because in addition, there's already a library of GitHub actions provided by GitHub themselves, and there's a community around packaging popular software into these GitHub actions. And also we, at Popper, a lot of the work we do is packaging things that are commonly used in research for, we package software that is commonly used for research into these actions, and we have a library of actions that can be used for that, and that's a lot of the work we do. And we also have a lot of examples of Popper being applied in different fields. We have some like genomics workflows. We have database research workflows, operating system research. It's really most things that need this sort of reproducible workflow computationally, you can define them through Popper. So here, instead of having this artifact description appendix, well, we could just package in a workflow, a Popper workflow that does exactly this, and it would greatly simplify the reproducibility of these supercomputing papers. Well, I say we, but actually Evo is working with a lot of the people over at supercomputing to get to allow Popper workflows to be used in these artifact descriptions at first, but we like the idea is that at some point we could allow these instead of them. So there was this, Evo gave this workshop about it, and another idea that we're working on and that we're really excited about is the idea of automatically validating or evaluating these artifacts on the cloud, basically. We have this system where you can commit a change to your experiment, and once you push it to GitHub or whatever code repository you're using, it'll trigger a job to one of these. They're called continuous integration services. That'll basically it'll run your experiment automatically, and we have actions to work with many cloud providers. We support Amazon Web Services, DigitalOcean, and research clouds like Cloud Lab or Chameleon. We have actions that say, well, I need to run my experiment on 10 machines, so can you give me those? So you can run your experiment on any of those, and once the experiments are done, we can generate figures, we can generate result data sets, and with that we can have validation logic exist inside the code itself, and we can keep track of what the status of that experiment is through every change that is committed. And that's it for automated validation. So Popper currently, it's been accepted for the cross incubator fellowship, which means that we're gonna keep working on it, and the current goal is to find a self-sustaining model, so we don't have to rely on the incubator forever. That's kind of the point. And we have several ideas on building platforms for running proper projects and how we could maybe take the project to the next level. And here's a couple of projects that run experiments in Popper. I don't know if you've heard of it, there's a Ceph storage platform that's being developed at Red Hat. They run a lot of experiments on Popper, and as well as it's used a lot by some researchers at the Genomics Institute at UCSC. And of course, it's getting some traction at SC19. So we're kind of excited for that. And yeah, I think that's it for me. We have this workshop. Well, when we run workshops, we usually use this we call it software carpentry. If you want to check, I'm not sure if we're going to use this tomorrow, but if you want to check this out, this is basically like a step-by-step walkthrough of Popper. It goes through like the basic concepts we use for things and how we would convert an existing workflow that just has a bunch of scripts into a workflow that runs automatically with Popper. And well, I encourage you to check that out. Thank you.